Hey, hi everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is count largest group. The problem category is of easy level, and I would say the problem is quite easy to solve, and we are going to solve it in time complexity of O of n and space complexity of O of n. What's given in the editorial is a time complexity of O of n log n. We would try to optimize the solution, and that is the goal of this video. The given input in this problem is an integer which is n, and the range of the value for the integer n will be from 1 to 10,000. The output which we need to give is the number of groups with the largest size. Now, how can we form a group and how can we find the size of it? It depends upon the task. So let us try to understand what is the task which we need to do based on the given input. Now, whatever input we are given, let's say the value of n is 13. What we need to do is we need to first find the sum of digits from 1 to n. So if n is 13, we need to find what is the sum of the digits for 1, for 2, for 3 till 13. Okay. Then we need to create groups. So coming back to the output, we need to find the number of groups with largest size. So now we will try to understand what are these groups. Groups are the numbers with the same sum. It means if you are trying to find out the sum of digits from 1 to n, there are different possibilities of the sum, right? We just need to group those numbers which are having the same sum. For example, 1 and 10 will be in the same group because the sum of the digits for 1 is 1. The sum of the digits for 10 is 1. So both have the same sum, right? Then we can say that 1 and 10 will belong to the same group. 1, 10, 100, all these will belong to the same group because they are having the sum of the digits as 1, 1 and 1. So we need to create the groups of the numbers which are having the same sum. That is, the digits sum are same. Now, next is you need to find all those groups which have the highest size. Now, this size means the number of elements. So if you form a group of 1, 10, 100, the size here is 3. So once you are able to find out all the groups, you just need to find out all those groups which are having the highest size. Okay. So there might be a possibility that there are multiple groups, or I can say many groups which are having the same size. For example, 1, 10 and 2, 11 both have the same size. Both have same number of elements, 2 and 2, right? So I can form multiple groups who are having the same size. I just need to find out all those groups which have the highest size. And then I just need to return how many number of groups I have which has the highest size. So let us understand this with an example. So if the given value of n is 13, what we need to do is we need to find the sum of digits from 1 to 13. So the numbers are 1, 2, 3, 4, till 13, right? What are the sum of digits for these numbers? These are, for 1 it is 1, for 2 it is 2, for 3 it is 3. Till 9 you will see that for 9 it is 9. Then for 10 it is 1, because 10 then we have 1 and then we have 0. The sum of the digits are 1 plus 0, which is 1. For 11 it is 2, for 12 it is 3, for 13 it is 4. For 13 I can say 1 plus 3, right? So it is 4. So we have completed the task number 1, which is finding the sum of the digits from 1 to n, right? Next is we need to create groups. We need to group the numbers with the same sum. Now out of these sums, you need to find what are the numbers which have the same sum. So we can say the number 1 and number 10 belongs to the same group. The number 2 and number 11 belongs to the same group because they have equal sums. We have another equal sums. We have 3 and 3. So we can say 3 and 12 belongs to the same group. We have 4 and 4. So we can say 4 and 13 belongs to the same group. The other numbers are having some like 5, 6, 7, 8 and 9. So they will belong to a separate groups. 5 will be a separate group, 6 will be a separate group, and similarly 7, 8 and 9, they will be separate groups. So from here we can say that we have found the groups of the numbers with the same sum, and the groups are 1, 10, 2, 11, 3, 12, 4, 13, 5, 6, 7, 8, 9, right? Now next is find all those groups which have the highest size. So what are the size of these groups? The size are 2, 2, 2, 2 because these groups are having two elements, 1 and 2, 1 and 2, 1 and 2, and 1 and 2. For these groups, the size is going to be 1, and that's because these groups are having one number of elements in it. So the different sizes are 1 and 2. And what's the highest? 2, right? 2 is the highest. And that is what we need to do. Find all those groups which have the highest size. So these are the groups with the highest size. And then you need to return the number of such groups we can form. So we have 1, 2, 3 and 4. 4 groups which have the highest size. And that is why the output in case n is equal to 13 is 4. Now the process to solve it is going to be really easy. So let us try to understand the process and also optimize the process as well. So we have an approach, and that's basically a brute force approach. We will see where we can optimize this. There is not a lot of scope to optimize it, but we will still optimize it because the solution in editorial is n log n, and I would say O of n is possible. I am talking about the time complexity. So what we can do is we can run a loop from 1 to n, right? Because we need to check for each numbers 1, 2 till 13 if the value of n is 13, or till n for whatever n is given in the input. Then you need to find the sum of each digit, right? So you run a loop, and for each digit 1, 2 or whatever digit is there in the loop, you can find the sum of those digits, and then you can store it in a map. The map will have a key as the sum, whatever sum we are finding, we need to group it. We need to group it together, right? So we are going to say we will have a map and the key will be the sum and the value will be the count, because we also want to know if this is a group with the sum 1, how many elements are there with the sum 1. That is, how many elements are there in the group. So this has the sum of 1, this has the sum of 2, this has the sum of 3, and if you go down, this will have the sum of 9. And these sums are having the count as 2, 2, 2, 2, or 1, 1, 1, 1, 1. I'm talking about the number of elements we are getting with these sums, so that we can just group them. So we will have a map, the key is going to be the sum, and the value is going to be the count of how many such numbers have the same sum, right? So it's like saying that once I calculate the sum of the digits of my number, I'm going to see if I already have that sum in my map. If I have, I will increase the count. If I don't have, I will make the count as 1, right? So initially the count for all the sums we have is 0, and the moment we get the digit sum as a particular number, we are going to store it in our map. Then we need to find out the highest value which we have, that is the sum with the highest frequency, and then we are going to check how many keys has the highest value, and that is going to be the output. Well, if this seems confusing to you, once you will see the solution, this is going to be really simple. So how the map will work is, for example, the n is 13, so we have numbers from 1 to 13, right? Now what are the different sums which are possible? These are 1, 2, 3 till 9. That's because once we were finding the sum of the digits of our numbers, it was 1, 2, 3 till 9, and then again it was 1, 2, 3, 4. We have got like 9 unique values of the sum, right? So our map will have these numbers as the keys, and the values are how many times or for how many different numbers have I got this sum. So the values are like 2, 2, 2, 2, 1, 1, 1, 1, 1. What is the highest out of the values? It is 2, right? So we need to find the highest value, and then we need to check how many keys has the highest value. So we have 4 keys, 1, 2, 3 and 4, which has the highest value 2, right? So I can say the output for this scenario is 4. The main thing to understand here is how can we find the sum of the digits. For example, if the digit is 127, how can you find the sum? You will have to run a loop, right? You will have to check for 7, then you will have to check for 2, and then check for 1. So it is like saying that if you have 127, you break it into 3 parts, 1, 2 and 7, and then take the sum of each numbers. Well, this is fine, and this is not a bad solution. This is actually a good solution, but this is actually a brute force solution. We are just doing everything which is possible. We can actually optimize the process to get the sum, and let me show you how. The process of finding the sum, right, in an optimized way. Now the thing is, the maximum possible sum is 36 in this case, and that's because the value of n given in the question itself will not be more than 10,000. So the maximum possible sum is 37, and that is for 9999. Within this range, you will not find any other number with the sum of the digits more than 36. This is the highest sum with this number, 9 plus 9 plus 9 plus 9, right? So what we can do is we can actually create an array of size 37. That's because the array are 0 indexed, right? So 0, 1 till index number 36. And what we can do is whenever we are finding the sum of a particular number, that is the sum of digits of a particular number, we are going to increase the count of that index. Every index is just representing the sum which is possible, and we know that sum is not going to be more than 36. Now how can we find the sum? The sum of digits from 1 to 9 is going to be 1 to 9, right? And that's because the sum of digits for 1 is 1, for 2 is 2, for 3 is 3, right? So from 1 to 9, it is going to be 1 to 9. So there is a formula to find the sum. For whatever number which is given, I can say number mod 10, that is find the rightmost digit in the number and then take the sum with the answer of number divided by 10. So it's like saying that number mod 10, let's take an example of 5. So 5 mod 10 plus the answer of 5 divided by 10. Now what is this answer I am going to tell you? The first thing is 5 mod 10, which is equal to 5. And 5 divided by 10, it is equal to 0, right? The answer of 0, that is what is the sum of digits for the number 0, and it is going to be 0, right? So I can say 5 plus 0, which is 5. Now why this formula is useful? It is not much useful for 1 to 9, because for 1 to 9 we know that the number itself is the digit sum. But let's say now we got a number 52. If n is, let's say, 60, then we will have to calculate from 1 to 60, right? So we will calculate for 5, and then we are going to calculate later on for 52 as well, right? The one process is you can convert it to string and then take each number, convert it back to integer and take the sum, that is 7. That's one way. But we are actually trying to optimize this with this formula, that when you get a number, just try to find out the rightmost element, which is 2, right? So the rightmost element is 2. So I can say 52 mod 10 is equal to 2. That's the rightmost element. And then what is the answer of 52 divided by 10? 52 divided by 10 is 5, right? The remaining elements, that is 52 divided by 10, or the number divided by 10. What is the sum of digits for 5? You remember we have already calculated this. And since we have calculated it, we don't need to recalculate it. We can say the answer of 5 is 5. So the sum of digits in 52 is going to be 52 mod 10, which is 2, plus the answer of 52 divided by 10, which is 5. So 2 plus 5 is 7. Now you might say this is not much useful, but this is useful for bigger numbers. For example, 529. So again you will have to say 9 plus 2 plus 5, right? but we are not running a loop. We will not check for each digit. We are just going to fetch the rightmost digit. So 529 mod 10, that is 9. And then what is the answer of 529 divided by 10? 529 divided by 10 is the remaining digits apart from the 9 or the rightmost digit, which is 52. The answer for 52 we have already calculated. So now I don't need to recalculate it. So I would say this is 7, right? And this is 9. So 9 plus 7 is 16, right? So this is how we are going to optimize our solution. So finally I can say every time we find the sum, I'm just going to increase the count in the mapping, find the highest value, and then find the count of that highest value. So let me take you back to the code editor and let me show you how the solution will look like for this particular problem. So we are just going to create a DP, which is like a data dictionary. Initially we will have the sum of the digits of 0, and the sum of the digits for 0 is 0 itself. Then we create a counter, an array or a list of 37 elements, and that's because the maximum possible sum is 36. Then we run a loop from 1 to n plus 1, that is 1 to n. And then every time we are trying to update the value of whatever sum we are calculating in our DP table. So DP of my current number is equal to my current number mod 10 plus the answer or the DP of I divided by 10. This is something we understood from the theoretical part of this video. And then we are just going to increase the counter for whatever sum we just found out for my current number. So counter of DP of I is plus equal to 1. Then you can just find out the maximum value in my counter array and then return the count of that maximum value. And that is going to be the complete solution for this particular problem. You can just submit the code and you will see that this is actually a pretty efficient solution for this problem. So runtime wise, it is really good. From memory wise, it is just fine. And that's because we are optimizing our time complexity. So we will have to compromise something in the memory, compromise in the space complexity. But this is a pretty fair solution and pretty good solution for this particular problem. And that's it for this video, guys. If you found this video helpful, if you understood the problem, if you understood the solution itself and the approach as well, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to my channel. And I will see you guys in the next video. Thank you for watching this video, guys.